Oh, sorry about the glare there. Let's move that over. There we go. So we'll hit, so we got to get inverse sine. So we'll hit second and then our sine button. So there's the inverse sine. Now remember, these calculators don't do fractions, so we'll treat it like division. So 18 divided by 27, close parentheses, get in the habit of doing that, hit enter. We're looking at an angle, measuring to the 10th position, of approximately 41.8 degrees. So let's write that down. 41.8 degrees. Now that we know what angle A is, okay, we could then figure out angle B in short order. We could just take that value and subtract it from 90. All right? Pretty cool, right? So we can find sides and we can find angles with trig. So let's try a couple more. Again, in all of these cases, A and B, we'll be looking at A as our point of reference. So keep that in mind. So let's look. In this next one, looks like we've got an opposite side. We've got an adjacent side. So if we have opposite and adjacent, that sounds like tangent to me. So the tangent of angle A is equal to opposite over adjacent. And again, we're trying to find A to the nearest tenth. So we'll rewrite that. The measure of angle A is equal to the inverse tangent of 60 over 20. Now notice, in this case, since we're going to be typing this into our calculator, I haven't bothered to take the time to take 60 over 20 and actually simplify it. You can, if you'd like, you'll get the same answer either way, but we're going to be typing anyway, so I figure there's no point in wasting my time simplifying. So the measure of angle A equals, so again, just to help you out, let's show you how to type it into your calculator. So second, our tangent button, 60 divided by 20, close parentheses, get in the habit of doing that, is approximately, again, if we're measuring to the, what do we say, the 10th position, is approximately 16 and 7/10 degrees. Again, try to make sure that you're putting your unit on there, and the way we do it with angles, obviously, is with that degree symbol. All right, let's try another one. A in this case, notice I've got a hypotenuse. I also have an adjacent side. So that sounds a lot like cosine to me. So the cosine of angle A is equal to the adjacent side, so in this case 3, over 15, our hypotenuse. Let's go ahead and move that cosine over, so to speak. So the measure of angle A is equal to our inverse cosine of 3 over 15. So our measure of angle A is, so again, typing it in case you're still struggling here, second inverse cosine, 5 over, excuse me, not 5, I can't read, 3 over 15. And again, still measuring to the 10th position, so this is going to be roughly 78.5 degrees once we round. All right? Pretty easy stuff, especially if you got a calculator. Now, last but not least, solving a right triangle. If you're asked to solve a right triangle, what you're being asked to do is to find all angles, all angles and all sides. All right, so if I'm asked to solve each of these triangles, what it wants me to do is to figure out not only this missing side, so I'll label it as X for the time being, but it also wants me to figure out these missing angles as well. All right. Now, remember, for sides, since this is a right triangle, we could, in theory, use Pythagorean theorem. Since we have two sides, we could use Pythagorean theorem to figure it out. Well, notice I've got 5 on one side. My hypotenuse is 13. This is a Pythagorean triple. So I know that FH is going to equal 12. Okay, so you can use Pythagorean theorem, folks. In some cases, we don't have to reach for trig every single time. Obviously, we can if you'd like, but we don't have to. In this case, Pythagorean theorem is the way to go, so we know it's 12. So let's list that. So this is 12 units, whatever it happens to be. All right, let's figure out the measure of angles G and the measure of angle F. All right, and I won't do all of these with you, maybe just the first two, and I'll let you do C on your own. So let's do for G. So we've got all three sides to pick from, so any ratio will work. For the sake of argument, let's use 5 and 12. All right, so let's use 5 and 12. So 5 is adjacent, 12 is opposite. So if I have opposite side and the adjacent side, that sounds a lot like tangent. So tangent of angle G is equal to the opposite side, so 12, over the adjacent side, 5. To figure this out, we know that G, or rather the measure of angle G, is equal to the inverse tangent of 12 over 5. All right, so if we type that into our calculator, second inverse tangent, 12 over 5, close parentheses, we find that our measure of angle G is, let's see, what are we rounding to here? Let's see, rounding side measures to the nearest tenth and then angle measures to the nearest whole degree. Okay, well, let's look. So the nearest whole degree in this case would be 67. All right, now a point of order. If we know this is 67 degrees, right, and we know that this over here is ultimately 90 degrees, do we really have to use trig? Let's write that in. Do we really have to use trig to figure out what the other side length is going to be? Well, not really. We know there's 180 total. So if this is 67 and that's 90, that makes this 23. So the measure of angle F is 23 degrees. And there we are. Let's take a look at this next problem. We'll use a different color here to separate things. So let's look at this next problem. Notice we know that this is 90 degrees, this is 62 degrees. Do we really need, for example, that, for this being 62, this 90, do we really need trig to figure this other side out? And the answer is no. We can just take 62, subtract it from 90, and we'll get 28. So we know the measure of angle C, angle C, not 3, C is 28 degrees. All right. So now all we need are AB and let's see here, BC. So let's figure it out. For AB, we can use any of these angles here that you want. Let's use 62. So for 62, AB here is adjacent. Then we have hypotenuse. Well, adjacent over hypotenuse sounds a lot like cosine. So cosine of 62 equals, let's see, our adjacent sides, we'll call it x. We'll label it x2, over our hypotenuse, which is 10. So let's work through that. So we'll multiply 10 on both sides. So 10 cosine 62 equals x. We can type that into our calculator real fast. 10 cosine of 62, close parentheses, gives us a side length. We're measuring to the nearest tenth here. So approximately for AB, approximately 4.7 units. Now, since I know this is 4.7, what I'm not going to do is I'm not going to use Pythagorean theorem to go 4.7 squared plus whatever squared equals 10 squared. I'm not going to do that. Remember, that's a rounded number. I don't want to use rounded numbers if I can avoid it. And in this case, I can avoid it. Let's use this 28 degree situation to figure out the other part. So if I've got side BC in our 28, BC is adjacent, right? We got hypotenuse. Well, if we have adjacent and hypotenuse again, it sounds a lot like cosine again. So cosine of 28 equals, move our calculator there, cosine of 28, we'll move this up so you can see. Let's see, adjacent, which we don't know, we'll call it y, over our hypotenuse of 10, and then we can work it out from there. So 10 cosine of 28 is y. So let's type that in real quick. So 10 cosine of, I'm sorry, what did we say, 28, close parentheses. We're getting a side length of approximately, rounding to the nearest tenth, 8.8. Now, if you want to check your work, obviously we could do that. So in this case, if we know this is 8.8, well, let's try it real quick. So let's take the square root of 4.7 squared plus 8.8 squared, and we know our answer should be something relatively close to 10, and notice, it is. We get 9.97, again, if we were rounding to the nearest tenth, 7 would make this 9 round up to a full 10. So again, that's why I tell you not to use rounded numbers, because notice we're off. We're not off by much, but we are off by enough. All right, and I'll leave number or letter C here to your own devices. I figure you can figure it out on your own. So again, that gives you sort of the basics of trig. You know what the ratios are now. You know how to find missing sides. You know how to use inverses to find missing angles. You now have enough information to be pretty dangerous when it comes to trig problems. All right, and you now have the ability to solve a right triangle given very limited information. Notice in this problem, we're only given one angle and one side, but you could figure out your other sides and angles with relative ease. All right, best of luck to you.